Okay, so for part 2, let's look at that. For part 2, deduce the roots of W4 minus 2I. You need to find a substitute lah. So compare and contrast with the original equation, which is Z4 plus 2Z cubed plus 7 square plus 30Z. Okay. Okay. I will pause for a while. So the comparing is this. What I usually ask students to do is try and change the coefficient to the same. So at I on your coefficient, so for example, this is 5, this is 5, 50, 50, right? So this coefficient is correct. So you see this is plus 30, this is a plus 30, means you group this together lah. Okay, change this. And this one is a plus 7. So this one has to somehow be a plus 7. So you move it in, it should be, actually you can tell what is the substitute really. And then you need a plus 2 here. So plus 2 minus IW cubed plus 7 minus W square plus 30 IW plus 50 equals 0. Okay, so it doesn't take long for you to know I square is minus 1, I cube is minus I, right? So in other words, this could be changed to IW cube plus 7 IW square plus 30 IW. Okay, this is a pretty okay question, I think. So hence, replace Z with IW. And basically, you just need to solve IW is equals to minus the previous answer, 1 minus 3I, 1 plus 3I. Okay, that's about it lah. Okay, so from here, we are just going to get W equals to minus 2I plus I over I. Can cancel the I. It's 2 over I minus I over I. 1 over I minus 3I over I. 1 over I plus 3I over I. Multiply I. So side note, times I minus 1, so this is 2I. Can cancel the I. That's why I'm doing it like that, because it's easier. So minus 2I minus 1 times I. Okay, there you go. That's how you get your answer for the second one.